We thank our speakers and we move on with our program. Just 5 years ago, we couldn't even imagine how AI would permeate our daily life, our work. We couldn't assess the scale. But in 2024, the level of implementation of AI in business processes, meaning its application in at least one business function, raised from 55% to over 70% in just 1 year. These are global figures, and they are very impressive. What goes next? What happens next? We'll hear about it from Go Meng and his presentation. Professor of Shandong Academy of Sciences, Zinan Institute of Supercomputer Technology, Tsinghua University of Technology. Go Meng, the computing power era. Drive the acceleration of digitalization and intelligence.
Thank you. Good afternoon, ladies and gentlemen. My name is Guo Meng from National Supercomputing Center in Jinan, China. As you know, in the past few years, AI has made a great achievement in application and technology research. I'd like to discuss a bit more about the supporting environment, the computing power. So, what is computing power? Computing power could be defined as the ability to process information. It usually includes 3 topics: storage, compute, and analysis. If we talk about storage, it's just really to read and write. There's nothing more to get advanced processing of information. And compute is something related to mathematics. Analyze is something concerning to logic and intelligence. In the first beginning, computing power should be oriented from the brain power. If we look at maybe one of the smallest neural network of elegance, it has 300 neurons with 7,000 connections. It can help elegance to get in touch to the outside environment. And if we have a look at the fruit fly, it can use about 3,000 neurons with 500,000 connections to help them get advanced behavior to the environment. On the right side, the human brain has 100 billions of neurons with 100 trillions of connections. That number of computing elements makes human brain the most intelligent maybe machine of the world. Because of the rapid development of brain power, humans know how to learn, how to get food and resource quickly from the earth. So this is the reason why human is dominating all kinds of life on the planet. Let me ask one question. Who is the people has the most powerful human of the world? If the question could be changed to who can remember the most numbers in a short time, there's a championship that is called the World Memory Championship. If you want to get win in this competition, you must recite thousands of random numbers or maybe put cards in a few minutes. And if you want to do some calculation, for example, in the middle figures, 2 numbers with 7 digits do the multiplication. Guess how much time do you need? 1 second? 1 minute? The answer is 10 seconds. So if we're talking about something more complex, like how to get knowledge, it's more complex, like the beautiful picture of the Russian State Library. You know, there's a lot of knowledge with a collection of people's development of our generations. People can develop tools to expand all kinds of abilities, like lever, pulley, and different kind of machine to expand the physical power. And also, we innovate the telescope, sound locator, or different kind of sensor to expand the eyesight and hearing. But if we have a look at the computing tools, that will be more complex. For storage, in other words, memory, people discovered image, language, characters, and books to expand the memory ability. And discover abacus, machinery computer, slide rules, and modern electric computing processors for calculations. And the topic for this conference, AI, people directed neural network for analyze and inference. If you look at the development of different kind of computing tools, from 1,000 years ago to about 150 years ago, that's mechanics, abacus, slide rulers, and mechanics computer. And about 8 years ago to now is electronic or electric time that include vacuum tube and transistors. After we have transistors, especially the integrated circuits, because of Moore's law in the last more than 50 years, the transistor on the chip doubles every 2 years. That means from 100 millimeter to 7 nanometer, we have massive computing elements on the silicon chips. A few years ago, when people discussed about is Moore's law dead, because of great requirement of artificial intelligence, Mr. Huang and NVIDIA continue the development for 1,000 times speed up in 10 years. Now you know the principle how computer comes from, and now how to realize great computing power. If you have looked at the most powerful supercomputer in US, China, and Russia, that data is from the list of top 500. You can know that there are 4 important key factors to improve the computing power. The first is the advanced semiconductor technology, from 28 nanometer to 5 nanometer. You can get more benefit from the silicon technology. And next, you must know, you must have massive computing units. The leading computer has tens of millions of cores inside. And third, you must have very efficient network to connect different computing cores. A good topology and high bandwidth and low latency. Finally, in recent years, we need hybrid architecture computing because just the CPU is not easy to get performance at a power consumption limit. Now you have the fastest supercomputer, but it's not okay for now because if you look at HBL, the most important benchmark for evaluation of supercomputing speed, the efficiency is around 60 or 70%. And if you look at the real applications like simulation or artificial intelligence, you must do a lot of more work to emphasize the code design. There's a story 60 years ago. The Nobel Prize winner, this physicist Richard Feynman, said that there's plenty of room at the bottom. That means we can develop high-end technology to speed up, to find new physics as a nanoscale. And recently, some computer scientists published a paper in Science said that there's plenty of room at the top. That means you have to combine the software algorithm and hardware architecture together for the total achievement by computing. Now, I like to speak that there's plenty of room in physics. If we are reaching the limit of semiconductor physics, we like to explore different principles like quantum and photonics. And this is a hot topic in recent years to delve to the new computing power. Let's talk about some macro picture. There are a lot of device powers like household wind power that's related to mechanics. You can use force or Newton to elevate. And for the electric power, there's something related to the electricity. You can use watts to evaluate. And for computing power, it's something related to information. You can use instructions per set, operations per second, flops per second to evaluate. Computing power and the other powers development bring the industrial revolution and upgrading. There are two words, no matter what happens. The first is speed, second, efficient. We developed the method to speed up how to use the force that lead to the first industrial revolution. And how to use electricity efficiently, that lead to the second. And the computing power and related information technology help us to get into the third and fourth industrial revolution. There are different carriers for computing power, from cloud to edge. From cloud, we can use HPC, cloud, AI, and in the middle term, the network can we deal with information at the tube, the pipeline. And from edge, we have cell phones, mobile, PC, tablet, and even watch, and even the intelligent cars. If someday we can make the computing power as a basic infrastructure at the electronic power, it's very important to connect the different computing power together using internet or the computing power networks. I list some important topics of computing power edge. The first is research on new computing technology, like the advanced semiconductor technology, quantum and photonic technology. The second is develop the fast computing equipment to support the requirement. The third is construct the cost or energy efficient computing infrastructure. The fourth is building computing power network to balance the power consumption and computing output. Next is investigate simulating and AI applications to create healthy computing ecosystem. I'd like to talk a bit more about what we are doing now. I'm from Shandong province. It has long history and has the second largest population of China. And you may know Confucius, one of Chinese famous teacher, the teacher of all ages. And you may know the Qingdao beer that comes from Shandong province. Jinan is the capital city of Shandong province. It's very famous for its spring and water. I'm from the supercomputing center. It has long history in the past 40 years. And we developed and operated different kinds of computing facilities in the last 40 years, from the vacuum tube to the high-speed ICs. The speed up is about trillions in the past 40 years. We are operating Sengwei and Shanhe supercomputer. Sengwei is a Chinese homegrown computer with Chinese design CPUs. And Shanhe has massive CPU and GPU to supporting the AI research for recent years. And now we are building the computing power network across Shandong province. The first to connect Jinan and Qingdao, the two big cities. The second stage is to build a network across Shandong province. The third stage for now is to connect the most important computing facilities all over China. And using these computing facilities, we promote applications of supercomputing, like weather and AQI forecast, oil exploration, medicine, new material, new energy, and even agriculture. For example, we provide the leading computing resource to the weather and AQI forecast for the Ministry of Ecology and Environment of China. Now, the model is based on simulation. Very recently, we worked with some partners to develop AI method for the weather and AQI forecast. And this is the largest RF telescope of the world. It's called FAST. And it generates 10 to 20 petabytes data every year. Using our supercomputer, we help our astrophysicists to analyze the data. And now we like to find some AI tools help to deal with the signal generated by the telescope. We also supporting universities, research institutes, and companies from China to training their large language model. For example, ChatGLM is one of Chinese generative language model. And also there are some applications driven by AI, like the digital human. And also, using simulation, we can do some computing-aided engineering for chemical engineering, material equipment, medicine, bioengineering, using different methods, like from DFT to multiphysics. Now, using AI for science and engineering is a hot topic. We are also working on some new topics like photonic AI for the future. We like to build a prototype of photonic computing facilities together with our Russian partners. If you have looked at the recent development of China's computing facilities, just as President Putin mentioned on the first day, we encourage our international collaboration together with the homegrown technology. For the past 40 years, you can see we have developed a lot of Chinese brand supercomputer in China, and some of them have ranked the first place of top 500. And in recent years, according to the national strategy, there is the data computing in the West. China has built a lot of computing centers in different provinces of China to leverage the power consumption and computing output. Let's discuss something about the future. As you know, computing power first comes from the brain, the animal brain or human brain. And because of rapid development of human and human culture, we have a lot of computing tools based on different principles. For example, mechanics, electronics, quantum, or photonics. And now we are watching how to make it more smart and more intelligent in the near future. We like to compare all these technology to training, to develop new technology or tools to deal with intelligence. Maybe we can expect in the near future, we can converge the brain power and machine intelligence together. Finally, they need to achieve that target. The international collaborating is very important. We like to get close collaboration, international collaboration with you to develop massive parallel simulation and AI codes based on the current leading computing facilities. And second, to initialize the photonic AI collaboration. And third, I think is most important, is explore the AI application in science, engineering, industry, livelihood, etc. It's very important to balance the investment and outcome of the AI. Finally, I'm from Jinan, Shandong province. It's not far from here. It's only 6,000 kilometers away. By plane, it needs 8 hours, and through internet, we can connect at any time. Welcome to visit Jinan. This is our center. Thank you very much.
Thank you, Professor Goldman. Ваши аплодисменты.